Hello to everyone. Welcome to the Gideon Planetarium Observatory. Welcome to Cyprus. Welcome on Asteroid Day, June 30th. Greetings to everyone, and we hope you're all well in these turbulent and uncertain times, and that you and your loved ones are safe and healthy. So, because of the difficulties to organize events this year because of the COVID-19 measures taken by governments, we have organized this online event to represent Cyprus and the international community regarding asteroid celebrations. We're here to celebrate and to share knowledge and increase awareness on asteroids. So, thank you for being with us tonight. And I will share with you immediately our PowerPoint presentation, from which we're going to go through and describe some things for you regarding asteroids. So during this past week, many programs and events have been taking place during the last week, as I mentioned earlier, in many different languages and in many countries worldwide, with different speakers and panels. Last month, the Asteroid Day TV was announced, and this year is a cooperative plan with the European Space Agency, and this has allowed us to produce several Asteroid Day programs in French, Spanish, Dutch, German, and Italian, and hopefully next year we have some Greek programs. And this included asteroid experts and special guests discussing European planetary defense and asteroid-related activities aimed at the general audiences. So, asteroids. What are asteroids? So, asteroids are the remnants from the formation of our solar system. They are rocky bodies orbiting around the Sun, and they are also called minor planets. Large numbers of these can be found especially between the orbits of Mars and Jupiter. This area is called the asteroid belt. It is very widely known. Their sizes may vary from 1,000 kilometers across, like Ceres, for example, and to the size of dust particles. Well, some asteroids have more eccentric orbits, and a few of them pass close to the Earth, or they even enter the atmosphere as meteors. So, what is Asteroid Day? Well, the Asteroid Day, the International Asteroid Day, is a global movement that helps us to protect the Earth from asteroids. So, since the year 2016, the Gideon Planetarium Observatory was appointed as the Cyprus Regional Coordinator for Asteroid Day. Every year, the Gideon Planetarium Observatory organizes and coordinates events in Cyprus, but also online events which are available internationally. For example, if you follow us on the YouTube channel. So this time, the Gideon Planetarium Observatory organized this online event, and for the Asteroid Day, but all the year round we emphasize the importance of the knowledge on asteroids. In many of our programs, in many of our workshops and astronomy courses, we include sessions and information and references on asteroids. In addition, our team searches for new asteroids, and we are proud to have our own asteroid discovery. So tonight we're going to have a quick look on this global initiative for Asteroid Day and the role asteroids play in our lives. And we're going to have a chat about the Tunguska event, 30th of June 1908, an incredible incident, and the search for new asteroids. And we would like to invite you to join our research team. So, let's go back in time and look at the story behind the Asteroid Day. Let's go back in the year 2014, where these four guys, Dr. Brian May, astrophysicist, but also very well known as the guitarist of the band Queen, Danny Garimine, president of the B612 Foundation, the astronaut of Apollo 9, Rusty Schweikart, and the filmmaker Greg Richters co-founded the Asteroid Day. In the year 2016, the United Nations officially designated Asteroid Day as the International Day of Awareness and Education about asteroids. So, Asteroid Day is a dynamic awareness and educational program to inspire the world about asteroids. And through the Asteroid Day, we continue to inspire people in their minds to look up into the sky and to get excited about the planets and the solar system. It's amazing. Throughout our work, we share information and teach about science, opportunities, and risks of asteroids, and we also do search for new asteroids and discoveries. So let's ask ourselves a couple of questions. Why do we need to learn about these asteroids? Why are they so important? Well, to learn about their role in the formation of our solar system, how can we use their resources? Do they have some elements that we are interested in, some methods that we are interested in, that they can be of use for us? How can asteroids pave the way for future exploration? How can we protect our planet from asteroid impacts? Well, Asteroid Day, as you may have already realized, is celebrated worldwide on June 30th each year to mark the anniversary of the 1908 Tunguska event. Tunguska is found in Siberia in Russia, and in 1908, 30th of June, the event in Siberia is recorded as the largest impact in recent history. But what actually happened there? A relatively small asteroid, somewhere between 50 and 190 meters across, exploded in our atmosphere and devastated a region of forest. Thank God it was an unpopulated area, about the size of a large city, let's say a metropolitan city. So we know that occasionally the Earth can be in the wrong place or at the wrong time and it can take a hit from an asteroid. So as you can see on my slide, um, the radius of the area affected is 25 kilometers. A man was, it was reported that a man was pushed off his porch 60 kilometers away from the place of the incident, and the explosion was hit 1,000 kilometers away. It was calculated that the speed of this asteroid was 80,000 kilometers per hour, so it was an incredibly large explosion. So if you look at this slide, you can see an actual picture of the Tunguska forest on the 30th of June, and you can see the result. All the trees fell down, and it was like a bombarded scene. So this was a really incredible asteroid incident. So in this slide, you can discuss the rate of asteroid discoveries. You can see asteroid discovery number 1 series 1801. Actually, it was discovered by an astronomer, Giuseppe Piazzi, at Palermo Astronomical Observatory on January 1st of the year. So his year started very well and very exciting for him, but for humanity as well, because in the following years, a new asteroid was discovered on average once a year, and until 4 were known, of course, until Vesta 1807. And it took almost 4 decades for the next discovery for asteroid Asteroid. So if we move time a little bit fast forward and we go to April 2020, when we were also part of an asteroid search campaign, and there were approximately 9 new near-Earth asteroids being discovered every single night. So This acceleration in discovery rates was extremely slow in the beginning to get going, but now they have increased a lot. But still, it's not enough. So, following the identification of the first four asteroids, as I mentioned before, and that it took almost 4 decades passed before another asteroid was discovered in 1845. If you have a look, if you take a look on this slide, asteroid number 10 was discovered on 1849, then 100 asteroids by 1868, 1,000 asteroids by 1921, 10,000 asteroids by 1989, 100,000 asteroids by 2005, and by 2020 we have reached the amount of 1 million asteroids. So this huge leap in discoveries has been brought about by the dedicated use of telescopes, new software, more sophisticated software and equipment, robotic technologies that they were used for this task. And actually, this evolution began in the 1990s. So, this was not considered to be enough by the Asteroid Day panel. So, they have introduced the 100 times declaration. So, this declaration called the attention to the fact that the detection rates for the near-Earth asteroids needed to be increased by a factor of 100 times to more completely reveal the population of near-Earth objects and to understand how many of them could one day pose a threat to our planet, the Earth. So the good news is that the rate of discovery shows that no sign of dropping, but remains the best way to understand the near-Earth object population. So now the discoveries are increasing exponentially. So as new facilities come online, especially the Extraordinary Survey telescope housed at the Vera Rubin Observatory in Chile, the discovery rate will accelerate even further. And with these new discoveries, the challenge is not only to discover the actual asteroid, but a greater challenge is to track them and afterwards calculate their orbits. What you see here in this slide is an animation from the NASA Jet Propulsion Laboratory Caltech, and it's an animation that was published in the year 2018, and it shows the orbits of the known near-Earth objects at that time. They have increased since then. So, the more we learn about the near-Earth object population, the chances are that we will discover more asteroids making close passes to Earth. So, this highlights that even stronger cooperation will be needed between scientists and the space agencies, and even science communicators need to ensure that the public remains properly informed, and we must encourage a common use, worldwide use of all known resources and unknown databases and unknown science and technologies, to use them together, to combine them, to discover more asteroids. So in this diagram, we have a mission. It's called DART mission. This is the Double Asteroid Redirection Test. So an asteroid impact and deflection assessment, IDA. So this schematic shows the impact on the moonlet of asteroid Didymos. So this in the next couple of years, we're going to have this impact, and telescopes on Earth will take measurements, and actually they will measure the change in the moonlet's orbit about the parental body. So, as I mentioned earlier, the Gideon Planetarium Observatory is having some research programs related to asteroids, and we take part in asteroid search campaigns, and we also allow students and citizens to join our research team to search for asteroids. So here you see an image, and in the center of the image you can spot an asteroid moving. Well, we have these two stars, this triangle, these three stars. You can see here 1, 2, 3, and 4. 1, 2, 3, and 4 movements of a newly discovered asteroid. So we analyze the images that we get from these telescopes, and in this grid you see with the blue color the new discoveries, that the new designated asteroids by us. The red asteroids are designated already and they are in the database, so they come up as red in the image. We designate them in 4 different images. So this is our preliminary asteroid discovery. We have actually designated and proposed 476 asteroid discoveries, but we are very proud to have one already preliminary. And we initially named it KPO 316, which means Gideon Planetarium Observatory 0316. That was the 316th asteroid that we proposed, and it was actually a preliminary discovery that was later renamed 2019 AN16 in the database of the Minor Planet Center. This is the Minor Planet Center extract that we have received last night, showing the object 2019 AN16 preliminary asteroid discovery. This shows the orbit of it in our solar system, and here is the NASA JPL Caltech extract from their website, showing the orbital elements of our asteroid. And here is today's the latest orbital diagram from NASA. You can follow the link, you can make a screenshot, you can follow the link online later, and you can see the asteroids, not the orbit of the asteroid. So in this summer we have a big challenge for our students. Mid-July, around 12th July, we have an asteroid research campaign, so they can join us. It's free. Just give us a call on telephone number 99991111, or go to the website astronomycyprus.eu. Send us an email to the email observatory@cytanet.com.cy. You can find all the links on the website, or join our Facebook group, Gideon Planetarium Observatory, and follow these links to contact with us, and join our asteroid search campaign. But also help us to search some digital sky surveys that were already archived, because when we discovered our asteroid on the preliminary discovery on the 2nd of January 2019, we have realized that we have spotted it first, but it was also found in some in archives in the digital sky surveys back in the year 2017. So they are really important, and we need to take them into consideration. So Fireball on the 21st of January 2020, 199 reports in Cyprus, something really incredible. We believe that we encourage people to make reports, and we did a good awareness on the subject, and we encourage people to report their observations of the fireballs, and incredibly we achieved as a country 199 reports, and this brought us to the home page of IMO, the International Meteor Organization. We're proud for this, and to say thank you to the public of Cyprus We encourage licensed students to join our team in July for some continuous sessions every Saturday morning. 3 or 4 sessions we will meet at the Gideon Planetarium Observatory to calculate the meteoroid trajectories. So it's another challenge for them. We're here for them, and we need them to help us for the publication and for them to gain experience of real scientific research and publication. So it's a good chance for them to gain some experience of the world of science and asteroids. So I would like to invite you all to join our spacewalk and keep looking up in the skies and have in mind that these rocks, they contain the blocks of life. So happy Asteroid Day from Cyprus. Thank you for being with us. Thank you for listening. I would also like to thank my colleagues there on Asteroid Day board and my friend Gianluca Masi and all the regional coordinators worldwide for the good work done and for sharing resources. Thank you very much. Happy Asteroid Day. Goodbye from Cyprus.